We saw earlier at least a hand-waving argument as to how delta z is approximately equal to this expression. The total differential, we just replaced the delta z with the dz to make this thing instantaneous in a sense that's not all that easy to explain at this point until we do the epsilons and deltas. But the instantaneous rate at which, or the instantaneous change in z due to an instantaneous change in u and an instantaneous change in v would be given by this expression. And all you really need to understand at this point is that we're replacing the delta with a d, meaning that we're thinking in terms of very tiny changes in the u and v quantities, causing a very tiny rate of change in the z quantity. And it's very clear that if I just replace the delta u's and delta v's by du's, we accomplish something along those lines. So what we're saying is the changes in u and v result in a change in z at an instantaneous rate corresponding to the above. And we'll try to make this more clear and more rigorous a little bit later. This is called the total differential. If we plug in finite changes in u and v, we're going to get a good approximation to a finite change in z, provided that the u and v changes are small, and provided also that all these derivatives are reasonably well behaved. Now, easy to remember notation for this, and remember all we're saying here is that the change in z is rate of change of f with respect to x times the change in x, which is rate of change of x with respect to u, times du. And similar here, here, and here. You should be able to look at these terms and understand what they're saying in terms of rates of change. But the easy to remember notation is this. We simply replace again fx with partial of f with respect to x, xu partial of x with respect to u, and so forth, and we get this notation. I'm not going to read it to you, you just have to look at it. Well, okay, I'll read it. The differential, total differential of z is partial of f with respect to x times the partial of x with respect to u, plus partial of f with respect to x times the partial of x with respect to v. Contributions from change in u and from change in v through the rate of change with respect to x. And then similar terms with respect to y.